learning outcome 16 is our definition of half-life. And it's the time it takes for the activity of a source to half. And then learning outcome 17 then are the calculations that go with that. Go back to 16, sorry, briefly. You might also find other definitions like it's the time it takes for half of the unstable nuclei in a source to decay. Right? That's a perfectly valid description, but in my experience, pupils often remember this one better. They kind of forget to put the unstable part in the other definition, but just in case you come across it and wonder what it means. And then learning outcome 17 is all about carrying out calculations based on that. Now, unlike most carry out calculations ones, I would normally write a formula and then show you worked examples. There isn't a formula here. What there is a method, so I can really only go straight to worked examples to show you what I mean by that. And it kind of becomes fairly obvious, I think, once you've seen worked examples. So we'll do a couple of worked examples. So worked example 1. So we're asking you to calculate the activity of a source after a certain time. In this example, it's after 12 hours. That on its own is useless unless we know what the half-life of the source is. Right? So this particular source has a half-life of 4 hours, and the initial activity of 4,000 becquerels, remember. Our definition of activity, the units for that were becquerels. So the first thing we do is work out the number of half-lives. And we do that by dividing the time that we're interested in by the half-life. So we work out that it's 3 half-lives. And then what we do is, we know the activity started after 4,000, started at 4,000, sorry. So after 1 half-life, and it's quite important, I'm putting that number 1 above the arrow, because that arrow basically represents a half-life passing. The symbol often used for half-life is T, and then a subscript, a half. So we know that after 1 half-life, it will go from 4,000 down to 2,000. After another half-life, so this is my second half-life, it will go from 2,000 down to 1,000. And after 3 half-lives, which is what I was interested in, our final activity will be 500 becquerels. So a source has initial activity of 800 becquerels. "20 days later, its activity is 50 becquerels. Calculate its half-life." So it's similar in sort of structure to the previous question, but in the previous one you were given the half-life and asked to work out the final activity. In this one you're given the two values of activity and asked to work out the half-life. Now the numbers have been picked carefully here, and they should be in almost every example you will do. I'll discuss briefly afterwards what you do if they're not. But the numbers have been picked carefully so that if you do these, what are called chains with the arrows, so we know that after one half-life, so even though we don't know how long a half-life is, we do know that after a half-life that activity will go from 800 down to 400. We know that after another half-life it will go from 400 down to 200. After a third half-life, 200 down to 100. And after a fourth half-life, we reach the 50, which is given in the question. Okay? And let us say the values will generally be picked so that your final value appears in this chain. We'll talk about what happens if it didn't. So what we now know is that from 800 to 50 means that 4 half-lives have passed. So we know that 4 half-lives is equal to, going back to the question, 20 days. Now the half-lives don't change in value. So we can do a simple, if 4 half-lives are 20 days, then 1 half-life is 20 divided by 4 equals 5 days. And you can simply underline that as our final answer. Now half-lives can be fractions of a second, they can be millions of years, they can be anywhere in between. So the units of time that you deal with can be any, you don't need to convert them. Right? You just deal with whatever units of time you're given. If the final value didn't appear in one of these chains, so say I'd told you 20 days later its activity is 60 becquerels, and that doesn't appear in a chain, what you'd have to do is plot a graph. Because what you could then do is you say, well, I know that after a certain time its activity is at 100, I know after another certain time its activity is 50, and then if you draw a smooth curve, right, the graphs, remember, will always be like these smooth curves that we looked at. Right, they're going to be a smooth curve, then you could work out what the activity is after a certain time using the graph. But we'll look at some examples like that actually in the tutorials, or I think one example.